Okay, so the copy, you're going to kind of cut this off. So make sure you have that this says 6. And then this one says he. Okay. Is there anybody willing to read the story problem for us? Rain, thank you.
John gets his first job working at an ice cream shop because he loves ice cream. He gets paid $9 per hour. Create a table to demonstrate how much money John will make from 0 to 6 hours. Let S equal the number of hours worked and let Y equal the amount of money that he will make. Then create a graph with the results.
Very good. So it asked us to create a table for what set of hours? 0 to 6. Okay, so let's go our hours. 0 to 6. So 0, 1, 2, 3, 4, 5, 6. What did it say about money earned? Kylie. $9 per hour. So guys, if he works 0 hours, how much money does he make? $0. If he works 1 hour, how much money? 9. 2 hours? 18. 3 hours? If you're like feeling lost of like, where are they getting these numbers from? Who can tell me what you're doing right now? Valeria. You're timesing the 9 by the hours. So 4 times 9 is? And 5 times 9 is? And 6 times 9 is? Very good. Okay. Then it asked us to create a graph with the results. Now notice, there are no labels anywhere on the graph. So we have to add labels in. Which axis is this? Y-axis. Raise your hand if you can tell me what we should label the Y-axis. Go ahead, Raylan. Money earned, right here. Y is money earned. So on our Y-axis, we're going to write money earned. And with that, I'm going to put in parentheses a $sign. Okay, just to know what type of measurement of money we're using. Has anybody ever been somewhere where it is not dollars that is used for money, for currency? A few people? I'm assuming Mexico has been one for people. Where else? Anywhere else? Nowhere? In second period, we had somebody that had been to Korea and somebody that had been to the Philippines. I thought that was cool. Anybody else gone anywhere, like in Europe or anything? No? Okay. All right, so what about my x-axis? X-axis. What should we label that? Please stop talking. Thank you. Yeah, it's our hours worked. And then we don't have a title for this graph. What would be a good title of overall what we are talking about in this graph? Second period kind of thought that it was supposed to be like a sentence. No, not a sentence, just like a title for the graph. What do you think, Jackson? I'm sorry? I like it. John's earnings. In another class, we came up with ice cream shop earnings. Okay? So at this point, now we have to graph our points. 0, 0 is an easy one. What is that called again? Origin. Very good. So 1, 9 is our next one. 1, 9. This is kind of tricky because we're counting by 5s here. So 1, 9, we go to x value of 1. For 9, it's going to be in between the 5 and the 10. Is it closer to 5 or closer to 10? Yeah, it's right next to the 10. I know these are not going to be perfect, but we try to get them as close to possible of where they should be. So the next one is 2, 18. 18 should be in between what two set of numbers? 15 and 20. Is it closer to 15 or 20? It's closer to 20, but not right next to 20. Okay? 3, 27. 27 should be in between 25 and 30. Closer to 25. 4 is 36. 36 should be in between 35 and 40, closer to 35. It's right next to it. 5 is our easy one. 5, 45. Those are right on the lines. We like it when that happens. 654. Can I graph that one? No, it goes off the chart. We can't do that one. Okay? Once you have this fully graphed, I want you to look at what do you notice about the graph that you drew? What do you notice about it? Hallie. So what does that specifically mean? It is, very good, nice job. It is proportional. And then I'm going to add in what Hallie said first so that we all remember what that actually means. So it is a straight line through the origin. And just to help us remember, I'm going to write 0, 0 at the end so we remember that the origin is 0, 0. Okay? The next part says, what is the slope of the line? Remember, slope is rise over run, okay? So, yesterday, we made our slope triangle between 2 points. I'm not going to actually make you use your highlighter and draw your slope triangle, but we could still imagine what that's going to look like. So if you look up at the board, from this point to this point, how much did I rise? It was 9. Remember, we didn't go to 10. We went to 9. How much did I run? 1. Because you guys knew each time we went up $9 for every hour. Up $9 for every hour. Up $9 for every hour. So it's 9 over 1, which is just 9. Very good. Okay. So now comes the idea for the day. I told you we're talking about direct variations today. So if it says the example above is called direct variation, what do you think that means? From everything we've looked at, what does it mean if a relationship is a direct variation? It means it is what? What do you think, Kylie? I need a little bit more than that. That could be part of it. Not quite. What does it mean if it is a direct variation? Look at what we've done so far. What did you notice about this relationship already? What did you notice about this already? Hallie, what did you notice about this already? What did you specifically tell us that you noticed? It's proportional. Guys, today, direct variation is just a fancy way of saying it's proportional. Okay? So we're going to write, it means the relationship is proportional. So, thinking back to what we've done so far in this chapter, okay? Lesson 1, we talked about proportional and we talked about rate of change. Then lesson 2, we talked about slope. And we said how slope is the same as rate of change. So we said slope means the same thing as rate of change. We can call it change in y over change in x. We can call it rise over run. We can call it vertical change over horizontal change. We can call it y2 minus y1 over x2 minus x1. Or we can just call it the variable m. Okay? All of those mean the same thing as rate of change that we learned about in the first lesson. Now we're learning that direct variation is just another way of saying proportional. So far we've learned that slope means the same thing as rate of change, and direct variation means the same thing as proportional. Okay? So that's the tricky part about today, is it's not really new. We've been doing this already when we've talked about proportional. It's just now we're looking at it in a little bit of a different way, kind of calling it a little bit of something different. Do you guys remember on Monday when we looked at our tables, how did we decide if the table was proportional? Not if they were linear, if they were proportional. What did we do? What over what? Say it out loud. Y over X. So guys, it should not be a surprise today that when I want you to find K is just Y over X. We've already been doing that, okay? We've already been doing Y over X, Y over X, Y over X. Are they all equal? If they are all equal, then we know it is proportional. So today, if it's proportional, it's a direct variation, and we have a K value. In this case, what was my K value? 9 divided by 1, and 18 divided by 2, and 27 divided by 3. All of these equal what when you divide them out? 9. So my K value is 9 today. All right. And when we have a direct variation, it's always going to be written in the format for the equation, y equals kx. That's important to understand today because a lot of times once we know it's a direct variation, they want you to write an equation for it. Okay? So our equation is y equals kx. That's the equation for the day. If that's our equation today, it says write an equation to represent the scenario above. So if the equation is y equals kx, and you know that k is 9, our equation would be, very good. That's it, y equals 9x. Once you know what k is, which again, we've been doing that, once you know what that is, you just write it in y equals that number x. And hopefully it makes sense that the equation has to be in that format, because you guys were already doing this. Do you remember how you said, you take this times 9 to get this, and you take this times 9 to get this? Well, what you were doing was k times my x equals my y. K times my x equals my y. So y equals kx. You were already doing it. You just weren't thinking about that you were making an equation with it. Okay? So now that we kind of understand what a direct variation is, we're going to start our actual notes for today. Okay? So here's the actual notes for the day. Do you guys know I'm recording right now? You've been a little extra chatty today. I thought they don't realize I clicked record. We're 13 minutes in already. All right, so here are our guided notes for today. Okay. Now, if you are a big writer, try to write smaller today, okay? Because I obviously did not make this part of it, okay? I made the back side, but I obviously did not make this part of it. And this part, honestly, some spots have a lot of room, and some spots have very, very, very little room. So try to write on the smaller side, okay? So it says direct variation relationships have a constant rate between all your x and y values. Remember again, when we did lesson 1 and we started with proportional, we said y over x, y over x, y over x. And if they were all equal, we said, yes, it's proportional because the rates are equal. Well, if the rates are equal, it's a direct variation. Okay? Then it says y equals kx. Write that in. Y equals kx is the form of direct variation equations where k is the constant multiplier, where K is the constant multiplier. And again, what we mean by that is, in this one, it was proportional, so it was a direct variation. And we know that because in each one, I could take my x value times 9 and get my y value. So there was a constant thing, there was a thing that I could multiply every single x value by to get my y value. Okay? K is also known as the, do you remember from your blue paper what we wrote down? K equals, do you remember what it was called? It's 3 words. Constant of, sounds like you're saying it. Proportionality, remember? Constant of proportionality. Constant of proportionality. Okay. Says direct variation relationships are also referred to as proportional. So today, basically, we're going back to, on Monday, the question was, is it proportional? If it's proportional, we also know today it's a direct variation. Then we can write our K value and we can write our equation. Okay? The last part is K is a special type of slope. So a special type of what we've been talking about so far this chapter with rate of change and slope and all of those things and M. It's a special type of slope where the slope formula, do you remember what the slope formula is? Yeah, y2 minus y1 over x2 minus x1, which is just a fancy way of saying change in y over change in x. Okay? So, K is a special type of slope where the slope formula as well as just y over x work to find the slope. Okay? The slope formula as well as y over x work to find the slope. And I'm going to add something in here. This is because when proportional, our change in y over change in x is equal to y over x. When proportional, our change in y over change in x is equal to y over x. And that's not something new. We talked about that in the very first lesson, on the very first part of the notes. Down here at the bottom, it said, if a relationship is proportional, the constant unit rate, our y over x, is equal to the constant rate of change, our change in y over change in x. And we saw that in the example that we did. If it's proportional, my K value is 3 because y over x equaled 3 the entire time. And my M value is 3. My slope is 3 because my rate of change was constantly 3. So when it is proportional, when it is a direct variation, K and M are equal to each other. When it is not proportional, when it is not a direct variation, they are not going to be equal to each other. So since today we're talking about direct variations, if there is a K value, if it is proportional, it will be the same thing as what the slope would have been. Okay? So if we're looking at this, the part I like the most of these notes is this part right here, where it talks about, is it a direct variation for different types of problems, what you might see it as. So we're going to keep referring to this a lot, okay? So for an equation, it says it must be in the form y equals kx. It has to be y equals kx. So in our first question, is it a direct variation? If so, identify k. Y equals 1/8 x. Is that in the form y equals kx? Yes or no? Yes, if you look at it, if you write it out right above it, it's right in that form. Okay, so I'm going to say yes. It is in the form y equals kx. Yes, it is in the form y equals kx. So what is my k value? And don't think too hard on this. 1/8. Very good. So k is 1/8. On the next one, is it a direct variation? If so, identify k. Again, if I write this right above it, y equals kx. Is that in the form y equals kx? No. Who can tell me why not? So what part's making it so that it's not? Yeah, we are subtracting 9 at the end. We're not supposed to be adding or subtracting anything at the end. So no, it is not in y equals kx form. So in this case, there's no k value to talk about because it's not in y equals kx form. There's no k value to talk about. Okay? I didn't really have room to do any of these as got it, so I put my got it's on the back. So once you have that written in, flip it over to the back. Okay? This one goes really quick. On the back, the top part says circle the direct variation equations. So look at these 4 equations and just quickly circle the ones that you think are in y equals kx form. Shouldn't take very long. Hopefully by now you've circled at least one. So the first one, should it be circled? Yes. What is my k value in this one? 3/2. Very good. Is this one in y equals kx form?
No.
Why not? Plus 8 at the end. Very good. Is this one in y equals kx?
No.
No, why not? Because of the plus 2 at the end. I've had some people say there is no k. Well, you're right, there is no k, but it's because they think there's no number here. Remember, there's always really a 1 there. It's because the addition at the end. Is this in y equals kx form? Yes. So what is my k value? -2. So these are the only 2 that are direct variation equations. Okay? Flip it back over then. Now we're talking about tables. You guys were really, really good at tables before. Remember, for tables, it's just that every time I do y over x, y over x, y over x, they have to be equal to each other. So let's write y over x. What is my first y over x with the numbers? Good. Make sure you do it in the right order. 4/1, not the other way. Next one. Next one. Next one. Very good. So if I simplify these, 4 divided by 1 is, and 6 divided by 2 is? So are these the same so far? So do I even need to continue? No. So is this proportional? So is it a direct variation? No. Why not? What did you say, James? What do you say? The rates are not equal. Perfect. That's the exact explanation we used the other day. The rates are not equal. Okay? The next one. Another table. So tables, we have to do y over x. So what's my first y over x, Chelsea?
0.5.
Very good. And my second one, Alexa. And my third one, Braden. And my last one, Aubrey? Very good. So let's simplify these. Actually use your calculator. Don't just trust the person next to you. 0.5 divided by 1. Yeah, you guys can do that usually in your head. 1 divided by 2. 0.5. This is the one I want to make sure you type in. 1.5 divided by 3. 0.5. And 2 divided by 4. 0.5. So, are they all equal? So, is it proportional? So, is it a direct variation? Yes, it is. Since it's a direct variation, there is a K value. James P., what is my K value?
0.5.
Yes, very good. Raise your hand if you can tell me what my equation is then for this direct variation. What is my equation for this direct variation? Go ahead.
Y equals 0.5.
Fantastic. Very good. Okay, we will continue in lab. Go ahead and pack up. So, we have done equations. Oh, shucks. Perfect. Okay. So, we have done equations so far. Equations have to be in the form y equals kx. We have done tables so far. In tables, you have to see, are all of your rates equal? Are all of the y over x equal to each other? On graphs, you guys already know this. If it was proportional, it was a straight line through the origin. So that's the same thing we're looking here. On number 5, is it a straight line through the origin? Yes or no? Yes, it is. So, is this one proportional? Yes. So, is it a direct variation? Yes. Please turn around. So, yes, we know it is a direct variation because it's proportional. And why did we know, Ella, it's proportional?
Because it's a straight line that goes through the origin.
Very good. Straight line through 0, 0. So if it's a direct variation, we should have a K value. So on this, I want you to find a couple points on the graph where you can tell exactly where those points are. Do you see any ordered pairs on here? Well, you can read them exactly because they are right on where the grid lines cross. Do you see any points on the line? Where's one, Jackson?
1, 2.
Yeah, right here. Do you see any others? This one is right at 1 and right at 2. Do you see any others? Breeza. Very good. So I like to use those numbers. Make it easy on myself when I can read them exactly. So I'm going to do my y over x to find my k value. Because remember from our paper this morning, we said to find k, we do our y over our x. That's what we've been doing to test if it's proportional. So it's y over x. So in this point, what was my y value? Anybody? This point, what was my y value? 2, and my x value was? So it's going to be 2 over 1. In my next one, my y value was 4 when my x value was 2. Okay? Now, you could have done one or the other. You didn't actually have to try both because we already knew it's proportional. And if we know it's proportional, we know they're all going to be equal to each other. So it didn't matter if we use the first one or if we use the second one, they will be the same. So what do we get when we simplify any of these? What is my k value in this case? K is equal to, what'd you say? K is equal to, somebody said it, 2. K is 2. Anytime we take our y divided by our x on any point on the graph, we will get 2. So then what is my equation for this direct variation? What would my equation look like, Carson? Y equals 2x. Very good. So this line has an equation of y equals 2x. That means any point on here, I could create any point on the line by plugging in an x value, multiplying it by 2, and then I'll get my y value. Okay? And I can see that like right here, this point. My x value was negative 2, so if I plug that in, negative 2 times 2 is anyone? Negative 2 times 2 is anyone? Negative 4. And look, my y value was negative 4. Okay, so this equation represents this line right here. Are there any questions on that one? The next one says, is it a direct variation? So when I look at this one, look at the line that we have, and basically you're asking yourself right now, is this proportional? So is this graph proportional? Yes or no? Why, Christian? He's saying no. I can't hear you. Kind of. What makes it so that it is proportional on a graph? It has to be what two things? Through the origin and straight line. Is this one a straight line? Yes. Is it through the origin? No. Which kind of comes into play with there was no rise there that you were saying. Okay? So on this one, no, it is not through the origin. Not through the origin. So if it is not proportional, it is not a direct variation. Is there a k value? No. Can we write a direct variation equation? No. So this is really it. We can't write anything else because there is nothing else to write since it's not a direct variation. Is that okay? Are there any questions with this so far? Okay, then we are going to flip it over and we are going to do tables and graphs on the back side. Okay, I'm going to start the problem with you. It says, Damon's earnings for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly with the number of hours worked. He has another job offer, and they are willing to pay him $7.50 per hour worked. Which job has a better pay? So he has his current job, and he has this other job offer. So I'm going to write down other job. So write down other job. If we want to know who has the better pay, we have to compare the two pays. Do we know how much the other job pays? Per hour. Yeah. It says right here, he has another job offer, and they are willing to pay him $7.50 or $7.35 per hour. So this job's willing to do $7.35 per hour. Okay. He also has his current job. Do you know his hourly rate at his current job? No, they didn't tell you, but we can figure this out. So, what I want you to do, because of the fact that you're going to have to do y over x, we need to know which one is our y and which one is our x. So if you look at this, it says assume his earnings vary directly with the number of hours worked. Do you remember how earlier in the week we talked about that you underline the two things it's talking about, and that should tell you which one is your x and which one is your y. What two things are we talking about in that sentence? Assume that his earnings vary directly with the number of hours worked. What are the two things that it talks about? Guys, I will 100% give you homework if you do not start to actually answer questions. This is honestly the worst some of you have been in class so far this year. Some of you are giving me absolutely nothing. Others of you are doing great. And others of you are driving me insane because anytime I look at you, you're not looking at your notes, you're not looking at the board, you're not looking at me. You're staring off into space, you're closing your eyes. And guess what? Now on the recording, anybody that's absent today and watches this knows you guys were not giving a good effort today. Try to focus. Try to pay attention. I know today is not an exciting lesson. I told you that this is my least favorite lesson of the year. Okay? I know it's difficult for some of you, but that's not a reason not to try. Okay. So, if we read this sentence, assume that his earnings vary directly with the numbers of hours worked. What are the two things we're talking about? Thank you. His earnings and the hours worked. How did we decide earlier in the week which one was which? And the one that came first was? But what letter? Y. Whatever came first is Y. Whatever came second is X. Okay? They actually added something else extra into this. They said the words varies directly. If it varies directly, that means, guys, that it is a direct variation. So we automatically know, if this is a direct variation, that this is proportional. If it's proportional, these are all going to be equal to each other. So do you have to try every single one? No. Pick one of them and do y over x and simplify it. So do that now. Find what he makes at his current job. Josiah, what numbers did you use?
112, 150,
Good. Guys, since it doesn't matter, since it's proportional, since it's a direct variation, since we know they're all equal to each other, you could have picked that. You could have done 90 over 12. Some people like to use this one because this didn't have any sense to it. So like 90 over 12 was a lot less than writing out the whole thing for $112.50. Either way, when you divide out any of these, what do you get?
$7.50.
Oh, what did I type in wrong? $7.50. I'm glad that you know that's 50 cents. Okay, some people don't remember to add on the zero when it's money at the end. So this one is $7.50 per hour is what he's currently making. So we have to actually answer the question now. The question says, which job has better pay? Olivia? Yeah. his current job pays more. There's going to be one like this on the quiz next week, where they're going to give you one of the rates, and you have to find the other rate from a table or a graph. And you have to compare them then. Okay? So we're basically just taking what you learned on this side of how to find your K value, whether it's a graph or whether it's a table. Find your K value and compare the K values. Okay? What would the equation have been for this one? If my K value was y equals 3.75, or if my K value was K equals 7.35, what was my equation for that one? If this is K, how would you write your equation?
Y equals 7.35x.
Yeah. If this was my K on this one, what would my equation be on that one?
Y equals 7.5x.
Yeah, very good. You didn't have to do that part, but that's what it would have looked like as an equation. Okay, so if instead, if they didn't tell you it was $7.35 per hour, instead if they gave it as an equation, that's how you would have pulled your K value out of that. That's going to be helpful in the next one. It says, Tom was comparing repair companies. The cost of computer access varies directly with the hours shown. I heard the word varies directly. That tells us what? If it varies directly, it tells us, yeah, it's a direct variation. Therefore, it's proportional. That means they're all going to be the same rate. Okay, we don't have to test every single one. They're all going to be the same. Okay, what two things is it saying that varies directly? What two things varies directly? Jacob.
The hours, or the computer access to the hours.
Not quite.
Cost of the hours.
Yeah, there you go. Computer access is the name of the company. Okay, so the cost for that company varies directly with the hours. So which one is my Y then? Cost. My X is my hours. So let's go ahead and look at computer access. On computer access, sorry, my pen's kind of given out at certain points. Okay, on computer access. When you're looking at this, pick a point on here where you can tell exactly what the two numbers are. Raise your hand if you can tell me where that point is on the line. Pick a point where you can tell exactly where it is. Go ahead, Braden. Fantastic. Okay, so I want you guys to come up with, from that point, what is that price? What is the price per hour? What is my Y over X? What is my K value for this one? So go ahead and do that. So what do we have? What did you do for the math? James, what did you do? What was Y over X? We all picked the same point.
50 over 2.
Good. And so what is that when you simplify?
25 over
Which would be just,
25.
so it's 25 what per what?
$25 per hour.
Very good. Nice job, James. $25 per hour. The other one then was the computers are us. What did they tell you about computers are us? Jackson. Yeah, you even went ahead of me. I was hoping you would just say that the equation was y equals 23.5x. So that means k is 23.5. So how much, Olivia, is that per hour? Good job, $23.50 per hour. So now that you know both of those, which company's repair price is lower? Which one, Xander? How much was it? Computers are us. Very good. So, computers are us has a lower repair price. So this is kind of an application problem. You have to take what you know about the table. You have to take what you know about the graph. You have to take what you know about the equation for a direct variation. And you have to find your k value for each of them and compare them. Are those okay? Are there any questions on that part? This is typically where people tend to get confused. This side is more of the basic problem. This side is the application. So are there any questions on those two? Okay, back to the other side. This one says the value of y varies directly. There's that varies directly again. If it varies directly, it means what? Yeah, it's a direct variation. It means it's proportional. Proportional means all the rates will be equal. Okay? So, it says if x equals 3 and y equals 21, what is the value of x when y is 105? So, we have to start with our y over our x. What y and x do we know together? If x is this, y is this, what two numbers did they tell us go together, Josiah?
X is 3, y is 21.
Yeah, if x is 3, y is 21. So those are the numbers we're going to use. We're going to say, okay, y was 21 and x was 3. What does that simplify to? 7. So Braden, what is my k value? 7. Aubrey, if k is 7, how would I write my equation? Perfect. Y equals 7x. Now, it went beyond, and it said, okay, if you know the equation, you know this is a direct variation, let's make a prediction from this. So what is the value of x when y equals 105? So I'm going to take my equation and I'm going to plug 105 into it. It said it was y, so make sure you plug it into the y value. That's right here. 105 is our y equals 7x. Guys, how would I solve for x in this case?
Divide 105 by 7.
Divide by 7 on both sides. So if y is 105, what does x come out to be? Do the math. Type it in your calculator if you need to. Evelyn. X equals what? Type it in.
X equals
good, Evelyn, 15. Okay. Are there any questions on that one? Yes.
Well, for like every equation, will it say very directly?
It will not on the ones on the back, I don't believe. If you flip it over, it doesn't say it on these, but it tells you that it says solve the direct variation word problems. So you know it's a direct variation for all of these, even though it didn't say it there. Does that make sense? Good question, Parker. Okay. So on this one, it says if y equals 8 when x equals 3, find your k value. Okay. I know there's more to it, but I just want you to find your k value. So find your rate, just that part. We're going to break this into steps. Just find that part. You will have to do this on 2 problems on your quiz. Think about what you do. You always do what over what. Think about it. It's literally what we just did over here. Find your k value. That's all I'm asking you to do right here. Just stop once you have k. So to find k, we do y over x. That's our rate. What was my y? Anyone? What was my x? Can you simplify 8 over 3? No. So k equals 8/3. So write your equation. Should only take you about 15 seconds at most. Write your equation. Direct variation equations are always in the same form. Josiah, what's your equation?
Y equals 8 over 3n.
Very good. So I have my k, I have my equation. The last part says solve for y. So now it says find y when x is 45. So what number are we plugging in? 45. What variable are we plugging it into? So guys, this time, this looks different than the other side. Make sure you're plugging it into x. So I'm putting 45 in for x. The rest of it is staying the same. So figure out what your y value is. What is y when x is 45? Raise your hand when you figure it out. Use your calculator. It's not that hard once you use your calculator, guys. You're literally just typing it in at this point. That's all you're doing. Aaliyah, when you type this in, what do you get? You're doing 8/3 times 45 in your calculator. What do you get? 120. So when x is 45, y would be 120. I want you to try the next one on your own. Find your k, write your equation, solve for the variable at the end. Okay, Xander, for my rate. Y over x. What was your y?
-12.
What was your x?
4.
So when you simplify, that's...
-3.
I'm sorry?
-3.
-3. So my k is -3. Very good. So then what is my equation, Braxton? Very good. For the last part, what number am I plugging in and where am I plugging it into?
-2 into y.
Very good. So I'm plugging in -2 to my y value this time. Make sure you did not plug it into the x value. It said y equals -2. That's a common error. So you have to solve this one. How do you solve? Not multiply. I want to get rid of the -3 on this side. That's a coefficient. This is really, in between is already multiplication, so the inverse is? What's the inverse? What's the opposite? No. I'm asking about the operation. It's already multiplication. So the opposite is? Yeah, so we're dividing by -3 on both sides. When you do that, x is equal to what? Yeah, I think so. Breeza. I'm sorry? So 0.6 repeating. Okay? You can write it as a decimal, or you can just keep it as this fraction. A negative divided by a negative is a positive. You can write it as 2/3 or 0.6 repeating. Okay? Any questions on that one? You really need to let me know if you have questions, because now what we're doing is this, except instead of just giving you here's y, here's x, they put it into a story problem, is what's left. So do you have any questions on what we just did? Okay. Back to this side. Says the number of words that Madden can type varies directly with the number of minutes. If Madden can type 225 words in 3 minutes, how many words can he type in 7 minutes? So, I saw what 2 words that I should be highlighting? Varies directly. That means it is a direct variation, which means it is proportional. That means all of the y over x are going to be equal to each other. So go ahead and write y over x. And they didn't tell us what was y. They didn't tell us what was x. So we have to use what it talked about as our y and our x. So if you look at the first one, the first sentence, the number of words that Madden can type varies directly with the time. What 2 things are we talking about that vary directly? Xander.
How many words you can type in minutes?
Good. Words and time, or minutes. Very good. So which one is my y value, Aubrey? Yeah, words came first. So I'm going to put words over minutes. Now we're going to know where our numbers go. So how many words, Braxton, did it say he could type? 225. And Braden, he could type 225 words in how many minutes? 3 minutes. So let's simplify that. 225 divided by 3, and we get, anyone? 75. So if my k value is 75, what is my equation for this, Evelyn? Okay, but I asked, what is my equation? And what would that be in this scenario? Did we already find k? And what was it? So what is my equation? I want my equation. Y equals kx. So plug in your k value. So what is the equation? Okay, do you see how my equation here was k was 7, so it's y equals 7x. K was 0.5. My equation was y equals 0.5x. K was 2, y equals 2x. If k is 75, what's my equation? Thank you. Very good. Okay. At this point, it says he can type, or how many words can he type in 7 minutes? Guys, was minutes my X or my Y? X. So I'm going to plug in 7 for my X value. So if I plug in 7 for my X value, what do we get in 7 minutes? How many words can he type? Go ahead. Good. The next one is the same type of story problem. The total distance in centimeters a toy car moves varies directly with the time in seconds. So again, I heard varies directly. What two things did it say vary directly? Josiah? Good. Distance with time. The distance is in the centimeters and the time is in the seconds. Okay? So it says the toy car moves a total distance of 204 centimeters in 12 seconds. What is the time in seconds the car moves when the total distance is 306 centimeters? So if we're doing y over x, which one is my y value? The centimeters or the seconds, Carson? So I'm going to do centimeters over seconds. Christian, what did they tell us for the centimeters? How many centimeters? Very good. In how many seconds? Aaliyah. Good. Simplify that for me, guys. Breeza, when you simplify it, what do you get? I'm sorry, say it louder. 17. So if that's my k value, k is 17, what would my equation look like, Braden? Say it again. Very good. Y equals 17x. So the last part says, what is the time in seconds the toy car moves when the total distance is 306 centimeters? Guys, centimeters. Am I plugging that into my y value or my x value? Yeah, look right here. We have it right next to the y. So we're plugging 306 into my y value. That means I have to solve this. How do I end up solving, Parker? Good. Divide by 17 on both sides. When I do that, I find that how many seconds does it take? 18 seconds. Very good. Flip it over. Go ahead and do the last one on your own. This one says directly proportional. That means the same thing as varies directly, just a heads up. Same thing as varies directly. On this one, hopefully you noticed that your distance traveled was your y, your time was your x. So distance over time. I put my distance of 93 miles over my time of 15 hours. When I simplify, I wrote it as a decimal, 6.2. That gives me k is 6.2. So my equation was y equals 6.2x. Then, since it wanted to know for 24 hours, that's time, that's my x value. So I'm plugging 24 into my x. 24 times 6.2 gave me 148.8 miles. Make sure you have all of that written down.